Hello students, my name is Sudhir Pavaluri. I am senior faculty in physics at IIT classes, and I did my MTech from IIT Kharagpur with a silver medal. I was the class topper during my MTech program, and I have a rich experience of 12 years in the field of IIT-JEE in teaching physics. And during these 12 years, I have sent around 100 to 150 students to IITs. Regarding physics, physics is very important subject in securing good scores either in JEE mains and in JEE advanced. And to understand physics, you need to have very good imaginative skills and visualization skills. After understanding or after visualizing the things, definitely solving a problem will be very easy. Generally people used to feel that solving problem is our first priority. No, which is not correct. Understanding the concept and visualizing the things, then applying the mathematical equation to solve a problem is the correct way of solving a question. In order to go through that process, you need to have proper training, proper systematic training. That proper systematic training we will provide at IIT classes with all our colleague faculty's support. Definitely physics is going to play a major role not only in JEE syllabus but also in your engineering career. Because in case of engineering, each chapter that you are learning here gets converted into a semester or 2-semester course in your engineering. For example, whatever the mechanics that you are going to learn here gets converted into engineering mechanics in your engineering, which will be a 3-semester course, dynamics of machines, kinematics of machines, and whatever the fluid dynamics that you are going to learn here, it gets converted into a 2-semester course for chemical engineering and mechanical engineering, and whatever the thermodynamics that you learn in your first year intermediate gets converted into engineering thermodynamics 1 and engineering thermodynamics 2. Similarly, whatever the electricity and magnetism that you will learn in second year is highly useful for electronics and communication people and electrical engineering pupil, which gets converted into power electronics for electrical engineering pupil, communication engineering and microwave engineering and engineering electromagnetics for ECE pupil. All these topics, whatever you learn at your intermediate first year and second year, definitely will be helpful. Whoever can solve the problems at this stage with the help of their visualization skills can excel in their career as engineers. That's why at IIT classes we will be with you, and moreover, as I have studied at IITs, I know the potential of IIT students. In case of IITs, definitely whatever you learn in your theory, you will perform it as an experiment in your laboratory. That's why every Indian student who is doing their plus 1 and plus 2 or intermediate, their dream is to become an IITian. So we will help you in the process of getting admission into IITs with the help of allied management. So I am going to be with you. This is Sudhir sir, who did his MTech from IIT Kharagpur. I am already an IITian, so I will definitely help you in the process of learning physics so that your scores in JEE mains and advanced will be very good. All the best. I am going to start my kinematics. Kinematics. Of course, before going into kinematics, you need to understand what I mean by mechanics. Mechanics deals with motion and causes of the motion, description of motion, and causes of motion. Under the description of motion, we will try to understand the behavior of a motion, which is known as kinematics, the chapter of kinematics. Whereas, who will cause that motion will be described in the chapter of dynamics. Who will cause the motion? Definitely you know that. forces will cause the motion and torques will cause the rotational motion. So motion related parameters, understanding the motion, we will do it in terms of kinematics, and causes of motion we will do it in terms of force and torques. Let us start to understand what do you mean by motion. You try to understand motion. Motion is always related to observer. Without defining observer, you cannot define motion of any body. For example, if a bus is traveling and you are riding a bike, you are on a bike. If both of you are traveling with the same speed, in the same direction, after 1 second, bus has traveled a distance of 2 meters and you also have traveled a distance of 2 meters. Hence the gap between you and the bus hasn't been changed, which says that the bus is at the same location with respect to this observer. Whereas your friend who is observing from here, he feels that bus has moved away from him, which says that with respect to your friend, bus has moved away, and he feels that bus has motion with respect to him. Whereas you, who is riding the bike, feels that bus is not moving with respect to you, because the gap between you and bus is remaining as it is, but the gap between your friend and bus is changing, which says that bus is under motion with respect to your friend, bus is not under motion with respect to you. Means who is making the observations is very, very important regarding defining motion. That is very important. That's why I would like to understand, first of all, what do you mean by observer? Observer, technically known as frame of reference. Frame of reference. In regular language, we will call it as observer. In technical language, we will call it as a frame of reference. We will define observer as the zone or the region which is making measurements. Probably from your previous classes, you may know how to define a frame of reference. In regular technical language, we will consider a frame of reference as a rectangular coordinate system, x, y, z axes. I hope you know from your previous classes, this is known as origin. This origin, we will define it as observer or frame of reference. So with respect to this, we are making observations. For example, you have a body which is at the location P. The position of this body will be defined by an x-coordinate, that is distance of this point along x-axis, and a y-coordinate, that is distance of this body along y-axis, and a z-coordinate, distance of this body along z-axis. So the position of this body will be defined by 3 coordinates, x-coordinate, y-coordinate, and z-coordinate. If this body is at rest with respect to this observer, then x, y, z parameters won't change as time passes on. If in case this body is under motion, then what will happen? X coordinate changes, y coordinate changes, and z coordinate changes. For example, due to motion of this body, x coordinate has been changed to x dash, y coordinate has been changed to y dash, and z coordinate has been changed to z dash. Such thing with respect to this observer, is said to have motion. So when you can say that there is a motion to a body, if the position of a body changes from one point to other point with respect to an observer, then you can say that the body is under motion. So a body is said to have motion in the position of the body changes with respect to an observer. Observer is very, very important. So this body is said to have motion with respect to this observer if the position of the body is changing with respect to the observer. Without defining observer, you cannot define motion. That is very important. So in regular mathematical techniques, we will consider this as the observer, which is the origin. Is it okay? Yeah, after understanding motion as the change in position of an object with respect to an observer or frame of reference or origin of the frame of reference, now let us try to understand the types of motion. Types of motion. In case of types of motion, we will try to understand translatory motion, rotatory motion, and combined translatory and rotatory motion. First of all, translatory motion. You try to understand what do you mean by translatory motion. If I consider this duster, I am moving it without changing its orientation. Then the paths followed by this particle and this particle. If I take up 2 points on this duster, the paths followed by both the points are going to be identical. Such a motion is known as a translatory motion. See, I'm giving you the same visual picture. If it is my duster, if I take up 2 points P and Q, if I move it such that the orientation of the duster is not going to change. I have moved it from here to here. See, the path followed by P, the path followed by P is this, and the path followed by Q is this. Have you observed? The paths followed by both the points P and Q are exactly identical. Such motion is known as a translatory motion. Now, I will take a same duster. What I will do is, instead of moving it like this, I will move it in this way, still without changing the orientation. You try to understand the intermediate positions of the duster while it is under motion. Suppose this is point P. Point P has moved in this way. So these are the locations of point P. Now, you focus on the path of Q. Q. Have you observed? The path followed by P and Q are exactly identical. Even though the duster is moving up and down, it is moving without changing its orientation, and the path followed by all the points over the duster are exactly identical. So you have to treat this motion also as translatory motion. Most of the students will have the misconception that they use it to feel straight line motion is only translatory motion, which is not correct. In case of translatory motion, what we have to realize the fact that if the paths followed by all particles are exactly identical, you have to treat the motion of the body to be translatory motion. What is the advantage with the translatory motion? Because the paths followed by all the particles are identical, equations of motion for all the particles will be same. Why to understand the motion of all points over the body? It is enough to understand only one point's motion, which will give information about motion of all the points, isn't it? That's why in case of translatory motion, you can reduce entire body to be single point. So in case of translatory motion, you can treat entire body motion as a single point motion on the body. That is known as point object approximation. In case of translatory motion, you can treat the body as a single point, which is important. And how to define translatory motion? The path followed by all particles on the body are identical. That is one point to remember. Next point is you can reduce entire body into single object. Entire body can be treated as a single point. It is enough to understand the equations of motion of single point. So that is the case of translatory motion. Yeah, after understanding translatory motion, we will try to understand pure rotatory motion. In case of pure rotatory motion, one point in the body will be fixed. This point I am going to fix it. Then I will rotate it. The body I will rotate about this fixed point, due to which the body position after some time will be like that, and the body's position after some time will go down, and the body's position after some time it will come up like that. Means I will take up this duster, I will fix one point, and I will rotate. It is rotating like that. So one point is always fixed. You take up 2 points over the body. You try to understand the path followed by those 2 points. Point B will follow a circular path like this. You try to consider one point, that point will follow a circular path. If I take up point Q, and point Q also follows a circular path. Have you observed the difference between translatory motion and rotatory motion? In case of translatory motion, the paths followed by all the particles are exactly identical. Whereas here, the paths followed are not identical. Have you observed? This path length will be more as compared to this path length. There is one difference. So, whenever there is a rotatory component for the motion, definitely, the paths are going to change from point to point. And in case of pure rotatory motion, one point will be fixed in the body and all other points will follow circular paths about that particular fixed point. Such motion is known as pure rotatory motion. Now, there will be third type of motion, which is combined translatory and rotatory motion. In case of combined translatory and rotatory motion, it will be a combination of translation and a rotation. You try to understand. If I take up the same duster, the duster is getting translated at the same time, the orientation of the duster is also changing. Means it is translating and rotating. By the time it comes up here, its orientation will be like that. So it will keep on translating and rotating. Such motion is known as combined translatory and rotatory motion. If you can understand all these three motions, your mechanics will be over, which is 1/4 the syllabus of IIT-JEE. Understanding pure translatory motion, pure rotatory motion, and combined translatory and rotatory motion through simple equations of mathematics is very, very important. This analysis will help you in getting a very good rank in JEE Mains. I will continue my syllabus with pure translatory motion in my next lecture. All the best, students. I will be with Allied and I will be with you for next 2 couple of years, so that I will help you in securing good score in JEE Mains and Advanced.